Hello everybody, in today's video I'm going to show you how to make a parallax shader inside of Blender, as well as how to use that parallax shader to make some stylish looking like holographic round frame glasses, as well as adding a little reflection effect, I guess, using parallax. So yeah, let's start out by making our parallax shader, which is going to be a normal based parallax shader. Most of the tutorials I've seen online show how to just do like a world vector-based parallax effect, which isn't what I was looking for when I figured this out, because I wanted it to, work with armature deformation or shape keys. So this will work as long as the shape is the same. It'll behave the same from any angle. So yeah, we'll start out by making a plane, and by putting a new material on it. And then we'll make a new image texture. By the way, I heavily encourage you to enable Node Wrangler. I assume most of you have already enabled that. If you haven't, look into it. It's really good. So let's take a look at this. So we've got a texture. And now let's think about conceptually how parallax should work. I do have to note that the parallax we're making here is a very rough approximation. You wouldn't really want to use this for like PBR stuff. It won't work that well with it. Because it's not quite that accurate. But it'll work for stylized effects, as you already saw those glasses. Looks pretty swell. So let's look at this real quick. If we think that this is our plane that we're trying to render, and this is what we're trying to render inside of it, we'll see that we actually want to, when we look at it, this is going to be a texture distortion effect that we're essentially doing. So what we'd be doing is, if I add a mapping node here, is we're using some kind of information to distort this texture, scale or whatever, stretch this texture so it would look like it is further back than the actual plane it's being rendered on, right? And so if we just think about this, if we just imagine this is our plane that we're rendering on, if we look at it from the top, it's going to look basically the same. A little bit smaller, but we'll ignore that for now. If I move the camera up and down, you can see that the plane seems to move and stretch. Seems to move up and down. And if I rotate the other way, same thing here. It'll just move like that. So what we're going to try and do is we're going to try and measure the angle between the surface here, the normal basically, and the camera, and to use that angle on the X and Y to move the texture back and forth to fake that sort of depth. So how do we do that? Well, we can't just use the normals, because the normals won't tell us anything relevant to the UVs, because we're going to be doing UV distortion. So we need something that has to do with the UV and the normals. And in this case, there's something that Blender calculates for us, which is really useful, which is called the UV tangent. So you can just grab a tangent node and set it to UV. This is actually something that is necessary for normal mapping, which is why it's calculated for us. Because normal mapping is also a UV-based effect, basically, that needs this to function. But I'll just try and explain what this is. We'll create a quick geometry node. This will also give us some other information for later. But in here we have our normal, which you can see currently for this plane, it's blue. That makes sense because if we take a look at our gizmo up here, we can see that the positive Z direction is up like this, and that is blue. So you can see that works out. If I rotate this plane towards positive X, you can see it turns red. And if I rotate it to the Y direction, you can see it turns green. So this is just a world vector that is pointing, give me a minute. This is our normal, which is always going to be aligned to the face. There's always going to point upwards like that. And what we want in this case is we want the direction X and Y relative to this normal for the UVs. So if we take a look at our UVs right now, so this would be Y, I think. If I could do that. There you go. So we've got X and Y. If I take a look at my UV map here, we can see that the UV map seems to be a gradient. And if we separate this out, separate X, Y, Z, there's a direction that this is heading in. And you can see in this case the gradient goes from here to here, which is the X direction that I've already drawn in. Same thing for the Y, it's just in that direction. So what we want, or what we would like to have in this case, is this vector. But even if I rotate this plane around, it should still be aligned with the plane like this. And yeah, again, this is what the UV tangent is. You can see if I just reset this, currently it's facing in positive X, so it's red. If I rotate this thing 90 degrees, then you can see it's now pointing in the Y direction. So this is what we want. The only problem is that we still need our bitangent, which is the other part of this, which in this case is not calculated for us, but we can calculate using a vector math node, using an operation called cross product. Cross product, I won't go into detail on what it actually does, but it essentially will, if you give it two vectors, it will find another vector right-angled to the other two vectors, basically. So yeah, so we can just plug the normal up into the top part, and then our UV tangent into the bottom part, and then we'll get the correct bitangent, and we can just tuck that under here. And you can see that's currently pointing in the Y direction. If I rotate it, again, it all works. So this is the correct vector, and now we have our vectors. Now, we'll actually want to find out how similar those are to our camera vector. So Blender gives this to us. It's called the incoming vector. The incoming vector is basically just if you look at this pixel right here, and you draw a line in physical space from this pixel, or like this surface point, to the camera, then it just gives you that direction, like as a unit vector. So you can see currently here that's blue. Actually, it would be a little bit like in the negative X and Y, because it's pointing towards that if you look at these. But you can see it's pointing upwards. So that's just the camera vector. By the way, this is also useful for stuff like specular effects, for those that do dot product calculation. But that's what we'll be doing now, is we'll be using vector math again, and we'll use a dot product. Dot product, in this case, with unit vectors, can basically be used to measure how similar two vectors are. So that's what we're going to be doing, essentially, is we're just going to be comparing the UV tangent with the incoming vector, and it's going to give us a positive and negative sort of thing. So here, if we look at this now, you can see that this thing moves, and the gradient, the black part here, is just negative, so you can't see it, but it does give us the offset, and this is actually already our parallax effect. The only thing that we'll want to do now is we'll want to combine these two dot products into a vector themselves. So this is going to be X and this is Y, because this is our UV tangent for X, this is our UV tangent for Y, so this is X and Y. So there you go. This is already our, like, offset for the UVs. The only thing we'll do now to make this easier to use is first I'll add a small tidbit that technically isn't necessary, but I just think makes it look a little bit better, is by adding a tangent node here. That's basically just going to make the offset a bit larger at a steeper angle, like this, which just makes it so the plane doesn't like move slower when you rotate the camera more, because it is a linear value that it's giving you. So yeah, anyway, and then the next thing we'll want to add is a scale node, which is basically going to be the strength of our parallax, the distance that we're doing, which, yes, that can also be negative. We'll take a look at that in just a second. So we'll add a UV map node here, and then we'll subtract our offset from the UV map. And that is already the finished node, basically. So we'll just plug this into our image texture from before, and then you'll see this already works. I'll set this to clip. And then you can see our parallax effect works, kind of. Again, this is a rough approximation. This is not really that accurate, but it works pretty well. You can see it seems to look, it's pretty convincing. And once again, this does rotate. I'll disable the notational notes here. It does work from any rotation. We can rotate this around any way you want to, and it'll work decently. So, yeah. There we go. That's the parallax effect. The only thing that we'll do now to make this a nice finished node is go Control G, and then we'll go press N in the N panel, and we'll add an input. In this case, just a float, which is going to be our distance. I'll also rename the output vector to UV parallax UV. There we go. And then we'll just plug our distance into that scale node. There we go. And now you can see that if the distance is 0, this is just a regular UV because there is no strength. And then you can just play with the distance here, which, by the way, that's what negative scale does. It does make it look like the plane is in front of it, which doesn't make that much sense always, but there are use cases for this in case you would like to do that. So there we go. That's our parallax node. We'll just rename that, and then that's the first part done. And then we will move on to making our glasses. All right, so for our glasses, I'm just going to start out with a circle. Make a face, rotate it 90 degrees, move it over, and then we'll add a mirror modifier because we have 2 eyes. And we'll move it out a bit, and we'll duplicate this to make our frame. So these are the first object here. This is our lenses. And then the other part here, this is the frame. So we'll go in here, and then we'll add a skin modifier. We'll go into edit mode, scale this down, and then we can add a subdivision surface modifier, 2 levels, just to make it look nice and smooth. We'll enable smooth shading on this, and then we'll delete only faces, just because that might mess up some stuff. And then I'll just make a nice little bridge here for the nose. Enable clipping on our mirror modifier so we can have this in there. That's a problem I'll look into later. Then we'll go Control-Shift-B to bevel this, make it nice and round, merge by distance. There we go. And then we'll add the little parts that go over the ears here. Control-Shift-B. And there we go. That is basically the frame of our glasses done. Very simple, but yeah, there we go. So let's take a look at our lenses here. We'll create another new material. If you are in the same blend file as before, you can just go and grab the parallax node by looking it up. If you named it that, you've got your parallax node right there. And then what we'll want to do in this case is we'll want to grab an image again. So we can just start out on that. So the first problem we'll have is that this won't do anything. It's purple. And that's because we haven't actually made any UVs for our mesh yet. So we'll go into UV editing, go into ortho view, look at it from the front, and press U, project from view, bounds. And that's going to drape this out for us perfectly the way we want it to be. Then we can go back into our shading tab, and in this case, the back side of this won't work, so we'll enable backface culling and make sure that the normals are in fact pointing towards us. In this case, they are. And then the next thing we'll do is we'll try and enable our parallax. And you'll see that this side works, but something here doesn't seem to be working correctly. So the reason why that's happening is because the UVs on this are mirrored. Due to the way that tangents, or the UV tangents, are calculated, it's messed up basically by the mirrored UVs. So we're just going to go into our mirror modifier, and we're going to enable mirroring for the U axis or the X axis, and then we'll have perfectly readable textures there basically. And now if I enable distance on this, it's going to work the way we'd expect it to. So now what I'd like to do is I'd like to make some circles that we can put into our little glasses here. You could easily do this with a bitmap texture or just like a PNG, JPEG, anything. But in this case, we're going to make it procedurally because I don't want to use another program. So we're just going to start out by doing that. Also, you guys probably will learn a bit about making some procedural stuff with math. So here we go. We'll start out with a gradient texture. We'll plug our parallax in there, distance 0, so it's just going to be UV. And actually, I'll make a plane using our lens material. Is this our lens material? This is our lens material. There you go. Rename your stuff. There you go. So we'll start out with a gradient texture, and we'll set it to quadratic sphere. And we'll see that we'll get this nice little circle, but it's in the bottom left corner. The reason that is happening is because the quadratic sphere is generated at 0, 0. 0, 0 is in the bottom left corner, so we actually want to move it up here. So we're just going to add a vector math node and subtract 0.5 from x and y. And if we look at it now, you'll see that 0, 0 is right here. And if I take a look at our gradient, it's correct now, basically. The circle is in the middle, which is what we're looking for. Then the last thing I'll do is I will invert this. Inverting in this case, actually, we'll just do it with math. Inverting in this case is just going to be a 1 minus. So if you think about it, if you take 1 minus 0, you'll get 1. And if you take 1 minus 1, you'll get 0. So what that does is it inverts a color. So you'll see that what was 1 before, so the middle of our circle, that was 1, is now 0, it's black. And the outside rim, which was 0 before, is now 1. So this is an inversion, basically. And the reason we want that is because this is going to be basically our radius. So this is radius 0, this is radius 1, right? And then anything in between. Otherwise, it would be flipped. So, yeah. And then the last thing we'll want to do is we'll want to add another math node, and we'll want to use the compare function. So we plug that in there. And what compare is going to do for us, so just conceptually, or actually I'll just set it up first. So you can set the epsilon to something like 0.1, whatever, and then you've got your value here. So you can see what this does. It creates a nice little circle for us. The way this works is that the compare node will essentially take a look at your texture, or at whatever value you have, and it'll be like, for all of these values that are equal to 0.5 plus minus this epsilon of 0.1 in this case, if they're equal to that with the epsilon, make them white. If they aren't, make them black. So if we change this epsilon, you can see if we set it to 0, the only pixels that are going to turn white are ones that are exactly 0.5, which you can see there aren't that many. And if we increase that margin, you can see the circle gets thicker. So this is really useful in this case, because we can just set a thickness for our ring, and the value that it's actually looking for is our radius, which is what we were looking for before. So there we go. Now we have a texture. This is just on a regular plane, but if we take a look at our glasses here, you can see that our ring is perfectly on there. Like it works out exactly the way we'd expect. And now what we can do is we can turn this into a node. So we'll just go Control G, and then we'll just add 2 inputs, float inputs. One of them is going to be our radius. The other one is going to be our thickness. And then the input is going to be our UV. Or you can just call it a vector. And then the output is just going to be a value. Yep. Okay. So we'll just plug the radius into our value here for the compare node, and then the thickness into the epsilon. Maybe add reroute nodes, just so this is a bit more easy to sort of look at. There we go. And there we go. Now we have our circle node, which we'll rename it. There we go. And we can set a thickness, and we can set a radius for our circle. There we go. And what we can do now is we can increase our distance on the parallax, and then it's going to work out perfectly. You can see that looks really nice. And then the only thing we'll want to do now is we'll just duplicate this like 4 times. I think it's good. And then we'll just combine these all together using math again. We'll use a maximum node in this case. What it'll do is it'll basically it'll pick the maximum value that you enter, which basically means that if something is black and something is white, like one part is black, one part is white, it'll always pick the white part. And the reason we're not just adding them together in this case is because I don't want the values, like in case the white parts overlap, I don't want those to turn into values like 2 or 4, because that's the values output by our compare node are 0 and 1. And if you added them together with 4 different components, you'd get a maximum value of 4. So yeah, in this case, it'll just be 0 and 1. And we can just play with our distance now to get these nice little circles. this one. There we go. And now you can see we've got a really nice little tunnely effect for our glasses here. And then the last thing I'll do, now that we have this together, is I'll use a mix node. Rest in peace mix RGB. Set the mix node to color. And plug that into our factor. And then we can mix between two colors. In this case, on one I'll take this really nice dark purpley color. Something like that, I guess. And then for our other color, I'm going to pick a very bright, sort of purpley color. You can set the value to something like 5, and then turn the saturation down just a little bit, so it doesn't have full color. And then we can enable bloom to get these nice little, glowy effect in this case. So there we go. We've got our holographic part done. Next, as a quick sort of intermission, I'll just sort of make the gold shader for our frames. So we'll just go into our viewport shading, and instead of using the HDRIs by Blender, we'll add a sunlight, which will just rotate something like this. I don't know. There we go. We can increase the brightness on these to something like, I don't know, 3, 2. And then we can add a material to this. So in this case, I'll make a really lazy, I guess, toon specular shader setup. So we'll just add a specular BSDF. Then we'll set the base color to black, the specular color to white. And that'll give us this really nice metallic sort of glowy thing to work with. We'll set the roughness to something like 0.5. So we get a slightly more distributed sort of color range, or like value range, really. And then because I'm really lazy, we're just going to add a shader to RGB node here, and then a color ramp, which we're just going to set to constant, and then we can just add a few levels. So this is going to be our first brightest level. I'm just going to set this to, I'm going to also make this really bright sort of gold shade here. Then our next color is going to be a sort of gold, of course. There we go. So there we go. Maybe turn down the saturation a little bit. And then for our shadow, we'll just turn it into a sort of, I'll color pick the actual gold itself first. And then we'll just make it a bit darker, a bit more saturated, and we'll push it over into a sort of red-ish, I guess, sort of color tone. So less saturation, less brightness, a bit more saturation. There you go. That's already a really nice looking gold sort of color. So there we go. That's our gold shader. If you really want to, you could add an outline to this. I'm not going to do that today. Yeah, okay. So let's move on to our lenses and make the reflection effect. So we'll just grab a parallax node again. And in this case, we can abuse dot product once again to make a nice little diagonal line, sort of, or diagonal gradient to work with. So we'll just get vector math, set the distance on your parallax to 0 for now. We'll grab a dot product node, preview that, and then we can input a few values here. So in this case, I'm just going to go for something like 0.5 and then negative 0.25. So that's going to give us a nice little diagonal gradient. And what we can do now is we can use compare again to make nice little lines in there. So we'll just grab our compare node, and then we can change the epsilon here. And here we go. So we've got one streak here already that can move. If we set our distance on the parallax to something else, you can see it moves. It looks, it definitely looks like it is behind something. If you look closely enough, you'll see that it's parallax. But if you don't look close, it'll just feel like it's a reflection that's moving over the glass. So yeah, if we want to, we can add as many of these as we want to. So we can daisy chain these together. In this case, I'm only going to be doing 2. Because I really don't think you need way more than that. So you can just put a second one there and make one of them a little thicker. There we go. So this would already work. I think this would already look pretty great. In this case, I'm going to go a little bit haywire though, and make it look really nice and dynamic by making these little reflection streaks thicker towards the rim of the glasses. So the way that we're going to do that is by grabbing a UV map again, and we're going to try and get our gradient sphere on this again. So we're going to get a gradient node, quadratic sphere, and then we'll grab vector math, and we'll go subtract 0.5. So this is the same thing as before. We're just making a sphere. And in this case, we're going to do the same thing where we invert this, or go -1. I'll use a math node. It really doesn't matter, but the reason I don't really like using the invert node is because it's a color node. So it's basically turning your black and white into a color, and then you're turning it back into a black and white thing. So just use 1-. I mean, it really doesn't matter, but you know. So here we go. Now we have black in the middle, white on the outside, and we can add another node, which is going to be a power. So if you know math, you'll know that if we power numbers between 0 and 1, they'll actually get smaller, and we'll get this really nice distribution where there's super low values that increase like exponentially in a certain sense here. So yeah. So we'll just set this exponent to something like 9, I think. And then we can use this as our epsilon on these little reflections. And you can see that that already looks really nice. So you can see that's already really sort of stylized and interesting looking. The only thing we'd like to do in this case is actually make it so that the middle here is a little thicker. So the way we can do that is by using a map range, which is going to remap the values. So basically, you can turn a 0 into a 0.1. And there we go. So now whatever was 0 before is like 0.2 now. So now we've got a really nice little effect here. What we can also do is we can blow out the edge of the glasses like that, which I think looks swell. And then we can just do the same thing, add another map range node. Or in this case, actually, I'm going to turn all of this into one node that we can just reuse. So we'll just go Control G, and then I'll just add a this input value. What is that? That is our gradient input. Then we'll have a min thickness, and then we'll have a max thickness, and then we'll just plug those into our min and our max in the map range. And then we'll also want a position, which is going to be where the little light beam or the little reflection is going to be positioned, which is here, which is our value here in the compare node. So there we go. That is a really really goofy looking node, not going to lie. And then actually the one last thing I'd like to do is I would like to be able to control the exponent here. So we'll plug that into our exponent here, and there we go. So now, if our exponent 1, position doesn't matter. So we'll get max thickness here, which is going to be something like that. Minimum thickness, which we're just going to make very thin. And we'll use our exponent to make this nice and thin again. There we go. And then we can modify the position. There we go. So I'll just disable the parallax real quick so we can see this more clearly. And then we'll just duplicate this node group. I guess I'll call this reflection something. There we go. Plug this in here and then combine these. And there we go. And now we have our little light beams, and then we can adjust how thick they are. The exponent here, if we'd like to make them really big. So I guess I'll just keep this one at like 7. There we go. I think that looks pretty swell. there we go. I'll just modify the position one last time. And then we can enable our parallax again. And there we go. That looks really nice, I think. And now the only thing we need to do is to mix this into our actual shading setup from before, so this. And so in this case, we'll duplicate our mix node, and we'll plug this into our factor. And there we go. That already sort of works. It's the same color, though, as these little rings. So what we're going to do in this case is, obviously, you can just change the color of this if you'd like to something more sort of purpley, bluey. My bad, in case you can hear that. That's a phone ringing. And then what we'll also do is we'll add a map range node so we can make this sort of transparent looking. So we'll just change this max to something like 0.25, I suppose. And then we'll also add some more value here. So we'll set it to something like 7 and then reduce the saturation a little bit. And there we go. That is our glasses finished. Looking really nice. And with a fairly understandable, I guess, sort of parallax effect. I hope you guys can use this in some cool ways. Please tag me on like Twitter or something if you use it. And if you have any questions, leave them in the comments. And yeah, I'm looking forward to seeing people use this. Bye-bye.